And then alpha blocker response, alpha blocker non-response, placebo response, placebo non-response. Okay, and then enter. Now placebo non-response equals 27. Okay, you can generate the new variable as well if you want to know the total sample size 26 plus 17 20 30 43, right, for the first study, that alpha the alpha group. So you can generate the total sample size by combining A and B, that is total NA or N alpha. Okay, and NC as well, 16 plus 17 you can generate. In order to generate the new variable, now we use generate command. If you use SPSS, now you use compute, right? But Stata use generate, gen, or you can type the full word generate. But I'm not going to do that. Let's step forward to meta command. So the command that now we're going to use called meta n. Okay, have you got the do command meta n? Okay, let's
The
try.
variable in right hand side doesn't exist. The variable box, I don't know what happened.
This one?
Yes, it's not. Because we type list and then we cannot click the variables.
The command is called list, L-I-S-T. So what I list all the year A, B, C, D. Okay, all the year and A, B, C, D. Install the command. Have you got successfully? Yeah, enter. Okay, good. The Stata sent you the message command help is unrecognized. Oh, why?
Because this is Stata version 12.
12?
Yeah. So use Stata.
No, doesn't matter. Version 12 is okay. Yeah. Version 12 is okay.
ได้ค่ะแต่มันเป้เป็นเปิดต้องเปิดใหม่อันนี้เป้หวังดีมากเป็นไฟไปเลย
Even you can define random. That means we want to apply the random effect model, and you can label the study as well. So something like this that you can learn from help meta in command. But let's do together. Follow with name one.
Name.
Follow with name one. Equal author.
Author.
So we want to label with the auto variable here, right? With the auto variable here. If you want to add year as well, you add another command in this bracket, year 1 equal year.
มา
Okay?
year ว่า equal year EAR
Year 1 equal year. And then enter.
ALP ไม่มี
วงเล็บอันเดียว
อ๋อนอน
ผิดเหรอ
พิมพ์ผิดนอน ALP
Of model, the random effect model, the random effect or the fixed effect model. That the incidence of non-placebo and the incidence of response to treatment in placebo and the incidence of treatment response to treatment in alpha blocker are the same. So that the same number that ratio equal 1, right? So there is no treatment effect. That means so that the bold line here where the risk ratio equal 1 is the reference line, and then the dashed line that is the pool effect size. The pool effect size that is the pool risk ratio. Okay, the pool risk ratio. But we are not going to take a look at the pool risk ratio right now. What you have to look, you look at the point estimation of individual study, whether most of them go to the same direction or different direction. That is the first glance that you have to take a look for the forest plot. And secondly, you have to look at whether the 95% confidence interval of these 6 studies are overlapped or not. If they are overlapped, and that means no heterogeneity. The treatment effect here is the risk ratio. Now, across 6 studies seem to be overlapped, so that they should be statistically significant. Okay, so that's the first glance for taking a look of forest plot. Look at the lower limit of this study or upper limit of the first study, overlapped with lower limit, overlapped with lower limit, overlapped with lower limit, overlapped with this one, but not overlapped with this one. You see, further away, upper limit and now lower limit. Okay, so for the 2 studies, these 2 studies, so that you can see, particularly for these 2 studies as well. You see, upper limit not overlapped with lower limit of this study. You can see that further away. So that is a signal of heterogeneity. So you can glance the heterogeneity from forest plot at first glance, and then you look at the cock and Q test and the I-square. So you back to the result window. Back to the result window here. The result window here that heterogeneity chi-square 14.13. Okay, with 5 degree of freedom and p-value 0.015. Whether we fail to reject or reject this null hypothesis if the level of significance is 0.1.
0.1
Should we reject or fail to reject? Reject the null hypothesis, right? We reject the null hypothesis. Now, that the log RR1 equal RR2 until RR6. So that is at least 1 pair, or there are at least 2 studies are different. And that corresponded to what we just take a look at the forest plot, right? At least 1 pair that is different. Okay, the lower limit and upper limit of their studies are not overlapped. Okay, and then the estimated I square equals 64.6. That is moderate level, right? 25 to 64, that is moderate level. So either heterogeneity test or the I square is significant. For this case, both I square moderate level and the Q test is significant. So that means now we have to change the model of pooling here. We can't take a look not only within study variation. We have to take into account two sources of variation within and between study variation. Okay, so we have to account for both variation. So let's hit the meta n command. You can use your page up. Now you design for data extraction form and try to extract the data, dig the data at that time, in order to let you export the source of heterogeneity once heterogeneity is present. Okay, you have to export the source of heterogeneity. So that if we look at the characteristic of the patient, for example, like baseline age and total symptom score, or even the duration of the treatment. So that among 6 studies, age length from 29 to 49. Okay, age length from 29 to 49. That's quite varied. So that we might explore whether age is the source of heterogeneity, and the duration of treatment length from 6 weeks until 24 weeks. That is quite varied as well. And the baseline characteristic is not too much varied. Start from 23 to 26.3. So let's explore one by one. In order to explore the source of heterogeneity, we can use meta-regression. Okay, we can use meta-regression. So the meta-regression is similar to general linear regression that you are familiar with, but the outcome here is the log list ratio, because we want to look at what's variable that associated with the log list ratio or the treatment effect. Before we do that, now you have to generate the log list ratio. After we hit the command meta n, if you look at the variable window in the bottom of this window, you can see that meta n generated the new variable. Generated a new variable, so that the new variable can be meta might be different because I use 16 but underscore star, and then it lists all 6 variables that started with underscore. Okay, so you can see that underscore SS, that is the sample size of that study. Underscore ES, that is the log, the risk ratio. The risk ratio of that study. And underscore SE, that is the standard error of log list ratio. Okay. And then along with lower limit of list ratio, upper limit of list ratio, and the percent weight of each study. So what we need to run meta-regression, in order to run meta-regression, that the equation will be log
ต้องติดกันด้วยไหมไม่ต้องโอเคค่ะไม่ต้องนะ
log risk ratio of each study
ได้แล้ว
equal
หยุดทำแค่นั้นก็ดอกจันนิดแล้ว
beta I x I
โอเคก็คือมันเอง
that log list. The outcome is log list ratio. We want that you want to name. I name log r equal log. That is the function in Stata ln. The natural log underscore es, right? That is the list ratio that Stata generated for us. Okay? And then enter.
enter อืม
And then enter.
L ไม่ใช่
Ah. Are you okay? No?
L L ค่ะไม่ใช่ I
อ๋อ L
And then we generate again SE
เมื่อกี้ขีดโอ้เท่ากับ
log RR
อา
equal
จารย์เพิ่มคำสั่ง
underscore SE, right? Underscore SE log ES, right? We need two variables. We need two variables in order to run meta regression. One is the log list ratio, and another one is the variance or the standard error.
ES
Because you want to wait.
ES ตัวใหญ่ ES
And then enter.
enter
So we got two, right? We got two variables right now. You can list.
อะไรเนี่ย
อะไร
We generate log list ratio and the standard error of log list ratio. Don't forget to take log for underscore es because Stata generate list ratio, not log list ratio. But the standard error is the log scale already. So we don't need to take log again for the standard error. Okay? And that is open the bracket. And then click on the variable or you can type straight away SE ln RR and close the bracket. Okay? And then you enter.
ไม่เห็นมีอะไรขึ้นเลยเอาขึ้นมาอาจารย์ Oh, not alone.
Follow me exactly.
Please
I will replace this.
ไม่ได้พิมพ์มันมี
Replace. I'm not going to generate again. I will replace the previous variable. Use replace command. Replace SE log RR equal underscore SE log ES. Okay?
ต่อไปรีเพจ
And after that, let's check the standard error must be positive sign only, right? That's the standard
OG.
error, not negative sign.
ES ตัวใหญ่
And then you can use redirect command.
อ๋อเร็วเชล
And then you can use redirect command straight away.
ต่อค่ะ
Replace the
lon
standard
RR
error if you estimate
lon
the log scale.
L R แล้วก็ SE lon RR SE ตัวเล็ก
Replace equal
SE
log
lon
scale.
RR
Can you list the two variables log RR and SE log R?
เหมือนอยู่ค่ะ
Yeah, list. That's alright. That's correctly list two variables.
ต่อค่ะเม็ด
METRA
Log RR.
METAR
RKTA
Here. And SE
EG.
log R that you just generated.
แล้วก็ lon RR แล้วก็
The new variable SE log R.
มาอันนี้อะไร
WA
Yeah, you can take a look at your window, variable window.
SE lon RR
get?
ยัง
Alright, and then you type meta red command, follow this, and then enter.
enter
เอาเป็นขึ้นเอ๊ะทำไมไม่ได้
ฮะ
So you can see that without including any variable,
นอกนั้นเหมือนเดิม
that the I square 64.16, right? And this is the coefficient. If you exponential this coefficient, that is the to-risk ratio that we use meta n command. Okay? Along with 95% confidence interval for this. But right now, what we have to take a look that the method for meta regression right now is we use restricted maximum likelihood estimation, not the Simonian and late method. But you can select the Simonian and late method in order to get exactly the same result as what we had done from the meta n command. Let me take a look. Meta reg
คำสั่งเยอะจัง
จำไม่ได้ด้วยเนี่ยมีค่าเล็กไหมได้มีปะเนี่ย
Okay,
อา
MM.
จารย์ไปเร็ว
MM, that is moment method. So I define MM by the default. Now Stata use restricted maximum likelihood estimation. But we want to
อันเดิม
use
แล้วก็เติม
the Simonian and
NM
Late
เข้าไป
method, the same as that we had done for meta n command. In order to get that, you have to add option MM moment method, that is now refer to
แล้วก็เติ
the
มเว้นวรรค
Simonian and
mm
Late method, and then enter.
enter ฮะ
And you can see that
อะไรวะเนี่ย ME
the I square not much change
อ๋อ
actually.
ดึงไอ้นี่
This the I square. This is the
ดึง
overall
เว้น
pulling.
วรรค
Okay, this is the overall pulling, and the lower limit and the upper limit.
ไป MM
But the test here, the lower limit is lower than 0, and the upper limit is 0.95, and p-value equals 0.068. So regardless whether it is significant or not significant here, because it's different cases. I forgot to mention, if you move up to your result from the meta n command here, from this one, the lower limit is 1.07, the upper limit is 2.31. This is from standardized normal test. So you can see the test of risk ratio equal 1. I forgot to mention that we can test the risk ratio equal 1. Using standardized normal test, now with the p-value equals 0.021. So that we reject the null hypothesis that the risk ratio equal 1. Okay? 7 to 69. And the adjusted R square decreasing. And that's worse. It's happening. So that's mean age. And look at now the p-value, the standard coefficient, the standard error. The coefficient that is coefficient of correlation, beta coefficient, right? 1 unit of age increase, and that the log risk ratio increase 0.007 approximately. And this coefficient divided by standard error equal t, and convert t to be p-value. Very now association, but worse on that. Worse than this, that the tau square increasing and the I square increasing. So H should be the source of heterogeneity. We try
มันทำไม่ได้
now other field. 46.6%, which is not too bad, not too high, but not too low either. Even though that now the p-value of now the coefficient of duration is not significant, that is okay. But at least that the I-square decreasing approximately about now 20%.
เขาใส่นี่ไป expand มันลดใช่ไหม
Okay.
duration
So let's explore further. If we classify or recategorize the duration, we know that duration, the mean or the median is about 14. Okay, 2 weeks. Some duration and option detail. Sum means summarize. Now we want to take a look at mean, and option detail we want to take a look at the percentile, the distribution of this variable as well. The minimum is 6 weeks and the median approximately 13, mean is 14. So if you take a look at this, you can see if we classify like 14 weeks or longer or lower than 14 weeks, might be possible. Okay, so that we're going to generate the variable consisting of 2 groups. One is receiving treatment shorter than 14 weeks and another one is 14 weeks or longer. Okay? Okay, let's do together. Then, duration might have, I think, let me take a look. Alright, you have to generate. Then, the new variable called duration here equal duration greater than or equal 14. Very simple.
GR เท่ากับ DUR ATION มากกว่าเท่ากับ 14
So that duration GR, that the new variable that we want to classify into 2 groups with the condition that equal
ไม่ต้องเว้น
the
วรรค
original variable duration with the condition 14 or higher, and that will be 1, will be coded as 1, otherwise is 0. Or you can do one by one to make you more understandable. If you don't like this command, 2 in 1, you can type 2 commands. Then, duration GR equal 1 if duration greater than or equal 14. That we can get only 1 group. Okay, and then we replace the rest later. Okay, shall we do it? And that will make you understand easily. Enter. And you can see that if you enter, Stata gave you the message that 3 missing values generated. Because we do only one side, 14 or longer, right? And that we need to replace the missing. If you list all the duration, DUGR, if you list the variable, original variable, and the new variable that we just generated,
ใช่ค่ะ duration
and you can see that
ION เว้นวรรคแล้วก็ DUR
14 equal 1, 24 equal 1, 24 equal 1, right? So that made our condition, right? Our condition is 14 or longer, and we have to do another round that shorter than 14, right? Shorter than 14. So replace page up generate
ที่
command.
ต้องเป็น list author list author ก่อน list ก่อน list อันนี้พี่คุยแล้ว
So page up this command and then delete generate. Replace
A U T H O R
duration equal 0. Okay?
replace
Shorter than equal 0.
Replace.
Longer than
R E
14
P L A C E
or longer is 1.
เว้นวรรค
So we're going to replace
เท่ากับ
if the duration
เท่ากับ
lower than
เท่ากับ
ไม่
ศูน
ไม่
ย์
เหมือนศูนย์เลย
อะไรเนาะ
เหมือนเครื่องหมายอะไรอ่ะ
lower than 14
ตรงนั้นเป็นเครื่องหมายตรงไหนอะ
and then
คือ
enter.
อะไร
if
อ้าว
duration
And you can see that
Duration
duration
เว้นวรรค
mesh
น้อยกว่า
that was now that is that now we
น้อยกว่า
expected.
น้อยกว่าเว้น
We
วรรค
got
ก่อน
3 missing
14
and you can
อัน
list
นั้นแหละเลขอะไร
อันนั้นเป็นเลขศูนย์เหรอ
you can list page up the list command that you just listed and by this time no missing value.
ได้ได้นะคะ
Right?
เร็วมาก
We fill in all already 1010, right? 6 week that is 0. And then fit the equation. Page up the
List.
command with the red command.
list L I S T
And then you read
list เป็นวรรค author A
duration.
ตัวใหญ่ U T S O R เป็นวรรค duration D U R A T I O N เป็นวรรค D U R G R
Or you can do subgroup analysis straight away. But right now let's try with the red
ไป
command.
ใหม่อีกแล้ว
And then add duration gr.
ให้
It
แล้ว
should be
เม
similar.
ตา M E T A โอ้ยอาจารย์ไปเร็วมากไม่ทัน
อะไรวะ
ไม่ทัน
เมื่อกี้อะไรอ่ะ T A I G T A I G E
โคตรเร็วห้ามกระพริบปะ
So you can see that your I square decreasing a lot, 12% approximately. Continuous outcome. Before we move to continuous outcome, do you have any question? Oh, I forgot. Okay, another one that we have to assess, that is the funnel plot. Assess for publication bias. Now we have to assess publication biases. In order to assess publication biases, now you can now use, now one is the funnel plot and another one is the Eger thesis. Okay, we have to do both. But let's try now funnel plot now first and then Eger thesis later. Okay? I think we are funnel. Follow with log RR and SE log RR. Yeah. And in order to respond to treatment, or the other might try to set another study that to allow to assess the effect size or the treatment effect that is alpha blocker. And sometimes that small study that have low quality or that high study around here, high quality of the study that on the top of the funnel. So that now having less or lower effect size compared to the small study. So if look at the funnel, if the study fail in 95% along of the funnel, that shouldn't be the problem. But if there is at least one that fail outside the funnel, that you have to explore. Okay, and also these studies now two studies that had low quality, that very high standard error compared to the rest. So that there might be the small study effect. Tells data that we need acre test and then enter. Okay? So that the acre test that tests for asymmetry of the funnel, and it's labeled as no small study effect. But actually it tests for asymmetry. But as I explained that from the funnel, the study that play role, that the study with very low quality that is small study size. Okay, so that's why they name no small study effects. And the p-value is borderline non-significant. Because we have only 6 studies and only 1 study that deviated from outside the funnel, even though that it is non-significant, borderline, but by having looked at the funnel plot, look like asymmetry. So what we have to explore further is that whether asymmetry is from missing study or it is from heterogeneity. There are 2 sources of asymmetry of the funnel. One is heterogeneity and another one is missing study. So missing study that we are afraid is missing non-significant study. So that is publication bias. So what we have to do, we need to do further if any one of acre test or a funnel plot show asymmetry of the funnel. And SD. And
เว้น
then
วรรค n underscore alpha เว้นวรรค mean m e a n
อยู่ตรงนี้นี่
อ๋อ
มี
ฮะ
total AL
แล้วก็ sd total al แล้วก็ n
So
possible
what we need for
แล้ว
proving
ก็
we
mean
need-
total
we need
mean
N
total
mean
PL
SD.
แล้วก็
N mean SD
อ่า
as
ใช่
I mentioned at the beginning. N mean SD. So what I prepared the data for each study along with the sample size of alpha blocker, the mean of the symptom score, and the standard deviation of that symptom score for alpha blocker, and then the same format, 3 variables for placebo. Okay, and the mean here that the total symptom score measured using different scale. Use different scale. So in order to let us combine 6 studies together, that now we can use, okay, let's add another one, scale. And then into,
เว้นวรรค
Alright. So you can see that
comma
6 study
compared
again, and
คอมมา
5 over
คอมมาข้างหลังสเกล
5 study,
หลังสเกลเลย
5
แล้วก็
over
เว้นวรรค
4
CON
over 5 use NIN and only
PRE
one use
โอ
IPSS.
เค
4 study use the same scale and only 1 study use IPSS. If we want to combine them all together, we now have to standardize the mean. We have to pull the standardized mean difference. Okay, standardized mean difference. Because now they use different scale. Okay. If we want to purely for study, you can use unstandardized mean difference straight away. But we have only 5 study. Now we want to use the benefit of all study. So we're going to pull standardized mean difference. Standardized mean difference, we can calculate from now very simple that the concept just only